Thanks for joining us. I think it was, I was putting together the 2019 sort of prediction piece in January, well, before January. And I knew that there was a short list of people I actually wanted to call, and you were definitely like top of the list, so thanks for joining us. And when we were talking then, you were talking about the, one of the predictions that you made was that more product managers are going to be using AI or helping to shape AI systems. And to the point that, perhaps they would even be better than some data scientists at it. Why?
Okay, so good morning, everybody. So product managers and data science, there are a few assumptions we tend to make that I think are currently incorrect and are changing, and this is why this is one of my predictions. One of those assumptions is that data science and machine learning and AI is too abstract a concept for anyone else to understand. I think that's wrong. And that the people who are best positioned in an organization to recognize where the opportunities lie are not the data scientists and the technologists themselves, but they are the people who actually own the product, who live with it every day, who work with the customers and the clients, the people who are integrating all of that information to build the mental model of the vision of where that product or where that business is going to go. Those are the people who are best positioned to recognize where AI should fit into it. And so it requires two things. It requires that really deep product expertise, but it also requires a basic level of familiarity with what's even possible, what's hard, what's easy. And in this field, of course, doing it as the technology is sort of changing out from underneath you. And so my prediction is that every product manager who has a product opportunity that could be improved with AI or automation or data science or whatever you want to label it as, will be expected to bring that familiarity to their job responsibilities in the same way that we now expect every professional to be able to use an Excel spreadsheet, at least to build a simple model or understand one. We will expect that of product folks in the next few years. And I think we've actually started to see it happening. It's become, at least in my biased experience of the world, much more common for product people to be familiar with statistics and actually to be responsible for managing, again, some metrics of product success. I think we've seen that change dramatically over the last few years, and I expect this will be an expansion of that.
Yeah. And I mean, one of the things in the conversations with startups and different companies that we've come across is, and I'm sure it is central to the work that you're doing, is this idea that the evolution of companies applying more AI is also beginning to reshape that company culture. Can you talk a little bit more about that and sort of the different issues that may arise in that?
Yeah, I mean, from a cultural perspective, again, we have to unpack it a bit. I think there are a few things that happen. So one is that there's a shift from thinking about the product you build in a purely deterministic way to thinking about it in a probabilistic way. And I've seen this both at a business level and at a technical level. So from a technical point of view, for software engineers to really build fantastic applied machine learning systems, they have to make this mental shift from designing discrete deterministic software to designing a system that is probabilistically going to learn from data and make a prediction. And it may seem like a very simple thing, but it is a different way of viewing the world. So you go from thinking about numbers and totals to thinking about distributions and error bars. And then on the business side, you need to be able to think about things in that same way. So all of a sudden, you have to think about, you don't entirely control every aspect of the product in the way you necessarily did before. And so you actually have to think about what are the anomalies that could arise, what are the edge cases that might come up. How are we going to plan and design a product in a business around a data set that we may not fully understand ourselves? And so it brings up a whole host of considerations, positive and negative, allows a lot of space for unexpected things and creativity, but also brings up ethical concerns.
Yeah, and I think in some of the work you've done at Fast Forward Labs. You've gotten into sort of looking at the sort of stumbling blocks that businesses encounter when trying to move from that idea of we're going to start with that sort of the MVP, and that one or two systems, and then going from dozens or hundreds of systems, and that challenge. What are some of the issues that you've encountered with your customers on that?
So there's two things I'm going to break out here. One is that, just for context, I'd founded a company called Fast Forward Labs over 5 years ago. We do applied machine learning research and advising. It's now part of Cloudera. We joined about 2 years ago. Every quarter, we have an applied machine learning report and prototype showing some emerging AI capability in the context of an applied business problem. So specific examples are things like automated text summarization, et cetera, et cetera. Right? And in those reports, we spend a lot of time being very thoughtful about where is this actually useful? What are the applications for it that are going to have value? And then also, where can this go awry? Both at should you be operating in a regulated context? Here are the things you have to consider from an ethical point of view. Or also just like, where could it be vulnerable to adversarial attack, for example? And that's one set of considerations you have in this domain that you don't necessarily have if you're just sort of building websites, right? The second thing you're alluding to, though, is a much bigger problem. And here, I'll change that, actually, and say I'm using the word problem in the computer science sense of a really fun thing we want to do. So we'll call it an opportunity. Mm-hmm. Where a lot of folks today are actually really good at doing this, at least amongst our customers, which at Cloudera tend to be large enterprise and folks in traditional industries. So they're really good at doing this one time or two times or three times, but each product or each system they build is something they have built fairly in a one-off way. And they don't have a sustainable way to scale those systems, to maintain them over time. And like I have been a data scientist, I will tell you that still the state of the art in data science monitoring is we sort of look at the metrics once in a while, and the person who knows enough about the system sort of says, oh, that looks weird, I better go look at it, right? We are still developing what it means to have not just 3 things in production, but 13, 30, 330,000 things in production. And to be able to scale that capability, not just in the technical sense of each thing growing into its own, but having many things, and then being able to give that power to create those things to all of the people in a complex organization in a way that you have one sort of set of systems or small defaults for creating and managing it. That actually grows over time. And so there really are multiple layers of challenge that we as an industry tend to face today, or at least we see our customers handling. And so to sum it up, it's one around the individual product or business opportunity, and then the second is the organizational opportunity. And the last thing I'll say on that is just that this is not just a technology problem. You can't buy your way out of this one because it's a question of people and talent. It's a question of organizational structure, and most folks have an org structure that came from somewhere that has to evolve in some way to accommodate this. It's a question of combining with an existing tech investment, but planning for one that you might want to make in several years with an understanding that some of the technology you want to be using at that point hasn't even been invented yet. And so these are the fun things to think about.
Are there any specific sort of common mistakes that companies encounter when they're trying to go when they're scaling the amount of systems that they're deploying?
Yes, there are many common failure modes. We could probably spend the whole day just on that, but I'll pick a few. So one is that you have a team of data scientists or a data scientist or a machine learning person who makes the thing, and then they hand it over a wall to a data engineer or to somebody who deploys it and maintains it. And that handoff might involve something, and I have seen all of these in the real world, so I'm not making them up. This is not some like imaginary horror movie, but like somebody taking some R code and rewriting it in Java to put it in production. It will be wrong, it'll be wrong. Or they export it to PMML or some sort, which is an XML specification of the algorithm and parameter selection, and then it goes into production, again, managed by somebody else. Now, that's not as bad, but it's running on a different implementation in development and in production. And by the way, I haven't mentioned monitoring or updating it at all. And monitoring and updating it means basically going back to the beginning and back out again. And the subset of things you can do there is pretty constrained. So that's not good. Okay, or you have arbitrary code, and somebody now has to take ownership of that, but they don't understand why it was designed the way it was, or the knobs were tuned a certain way. This is just one failure mode, by the way. So when we think about how we actually, as intelligent people who want to do things that make sense, design these processes, we have to think about how we go through the process of collecting data, managing that data, making that data useful, and that means things like metadata management, both, again, because we might be required to do it for regulatory purposes, but also because when you have a lot of data, you want to be able to do it. We have opportunities to make data catalogs where humans are not even the only customers, where we might be using deep learning systems as customers of that data catalog. So there's one failure mode. Another one is having unrealistic expectations and no sort of metrics for success of these systems. And then I'll list one more maybe, which is very common, which is management and organizational failure around this set of technologies. And what I mean by that is that either in our customers, perhaps it's owned entirely by IT that approaches it purely as a purchase decision, not as a thing that the company should strategically own and develop. Or potentially it lives entirely in a line of business where they lack the IT knowledge or the ability to integrate in the existing investment. And you might be saying, like, you're presenting A and B and they both sound terrible. They are both wrong, right? But every organization is picking a wrong one that is best for where they happen to sit today. So yeah, lots of common anti-patterns at the moment.
Yeah. You mentioned earlier the challenge of the handoff between different teams. Have you ever encountered executives getting in the way of their own projects?
Every day. Where are you going with that?
I was just curious. I mean, we didn't talk about it beforehand, but I mean, like, if there were any, specific use cases or examples that you've come across in terms of people essentially sabotaging their own.
So that happens, I mean, I'm sure everyone here has stories like that, right? Some people sabotage because they don't have a realistic understanding of what is actually going on in the system. It's really never gonna succeed in the way they think it might have, even if there is a real opportunity there. And that's also, by the way, if you take away one thing from what I'm saying here today, the dirty secret of applied machine learning, especially in the enterprise context, is that you set out to solve one problem, you try it, and then you solve a simpler problem that gets you to the same business outcome. And that creative ability to sort of realize what's valuable, what the technology can handle, what you can do in a sustained basis, like that is what gets sabotaged by folks who may be managing or championing a project without really understanding what they're actually doing. The other way I see this go wrong from an executive point of view, frankly, is just land grabs and people wanting to own something and therefore not doing what's best for the entire organization, just doing what's best for their piece of it. And because, again, at Cloudera, we mostly work with folks in the enterprise or in companies that are on the one hand extremely well positioned for this, in the sense that they have a business, they've been operating it for some time, they have deep expertise in that business, they have a lot of data generally created as a side effect of operating that business. The thing that mostly inhibits them from success here is not the raw ingredients, but the ability to organizationally execute against it. And it's because they often come with a legacy operation that came from, operations research or business analytics or actuarial science, depending on where they came from. And it really requires, and you phrase this as executives getting in the way, but it really requires executives who are leaders to do this well. So I'll actually turn your question around and say that you cannot do this well unless you have that kind of executive with both vision and the ability to organizationally execute and sort of see their way through all of the challenges to do that.
Yeah.
So maybe we'll make it a positive thing.
Yeah. I know that you are a big advocate of boring machine learning. Can you talk about why you think boring machine learning is exciting and some use cases you've come across?
That's the oxymoron of the morning. So I think we need to make machine learning and AI boring again, because I think that the media, with no offense intended here, tend to fascinate on the nature of the technology, but not on whether it's actually useful or not. And this leads to a ton of hype around things that may not be eventually substantiated. It also, frankly, leads to some cultural challenges in our technical side of the AI culture, where people want to rush in and use deep learning. And sometimes I'll ask them, like, did you even try naive Bayes? And they're like, no. So when I say we need to make this boring, we need to make it about results and outcomes, and about using the simplest possible approach that will suffice to get you those results and outcomes. And if it happens to be mathematically cool, like, boy, will I be happy. But that's really not the point. And maybe I'm so vocal about this because it is a personal failing that, like, I could very easily fall into that trap myself. As for the kinds of boring outcomes I'm talking about, like, we have a customer that is a bank that has managed to reduce their call center costs by, I think last I heard it was 4.5 percentage points over a year. And they did it by taking a year's worth of calls, doing speech to text on those calls. So they got text transcripts, medium quality, doing a bunch of clustering of those things, having experts actually look at the clusters and say, oh, this is somebody calling about overdrafting their account, and this one is somebody calling because they're traveling and something's not working, whatever it may be. Figure out the actions people took to fix those issues, created a recommendation system, so when somebody calls into the call center, it gets all of their data from interactions with the bank, makes a prediction of what they might be calling about for each thing they might call about, gives a recommended action to mitigate it. And this turns out to, like, actually solve people's problems better. There's a feedback loop, so the customer service agents can actually say, no, it was none of that, it was this. It makes the system better over time. Call centers are the most boring thing I can think of. I would say nobody likes to call centers, except they found in doing this analysis that some tiny percentage of people actually just call the call center, like lonely people. Yeah. They're probably the same people who click on banner ads. That's the one thing y'all laugh at, by the way. Like, in a previous life, I actually did that analysis, and there is a tiny group of people in the world who will click on anything, and the rest of us just ignore them.
That's why they exist, yeah.
Yeah. The best-selling ad tech segment ever is just people who like to click on stuff. But all of that is to say, like, this is the most boring application possible, but it's financially meaningful. And then it had another effect, because they were able to use the system they built to start proactively reaching out to their customers to say, oh, hey, you just overdrew your account. Here's an action we can take without you even having to call us to help you, right? And that made everybody happier. So customers are happier, business is saving money, we reduce the total call volume. Super boring. Even the math is boring, right? Clustering is not, anything that we wake up in the morning and get super excited about. But the impact overall is extremely positive, and it's the kind of thing where these don't sound like large percentage points, but in data science, if you have a small percentage impact on a high value problem, you have made progress, right? So very significant. So that's the kind of thing I think we should see more attention on. And less on, just something because it says it's AI.
Yeah, and I want to make sure we have time for questions, but I know that Fast Forward Labs has some new research to share.
We do. So our applied machine learning research group, Cloudera Fast Forward Labs, is about to release 2 pieces of work. One on a new approach to deep learning for image analysis. We do have folks using some of these techniques to do things like interpretability of image analysis deep learning systems for QA purposes. And we have another one on transfer learning for NLP, so being able to transfer models to better and faster create systems with limited data sets. And I will put a link on my Twitter account to those things immediately following this. So I'm H. Mason on Twitter. If you're interested, we're going to have an online seminar on it, and that'll be available in a few weeks. So It's the first place we've mentioned it.
And one last thing, I was curious, because I know that Fast Forward Labs is focused on, issues of ethics and the like. It feels like one of the key phrases in 2019 is ethics washing and this sort of fabrication of, any concern with. Just want to signal basically that you're concerned with ethics and
Yes.
doing things right. What do you think leads to organizations into ethics washing, or the pitfalls and missteps that lead to that sort of
That's your
thing?
last question.
That's it. I don't know. Yeah.
So with the caveat that I'm a computer scientist and not a psychologist.
Fair enough.
I think that, so we have at Fast Forward Labs, we've written about the ethics of the algorithms we talk about in everything we've ever done, starting over 5 years ago. And it's because you cannot build these systems without thinking about how they go wrong. And if you're at all responsible, you're thinking about the impact that will have on your customers and on the people who are using your system, whether they even know they're using it or not. This might even be like you're working on fraud detection. What happens when you say something's fraud and it's not, and somebody's having a bad experience, right? So ethics is really important in building these things well. And I do believe that most people in this community actually want to build great products. But because of a lot of the backlash and attention that's been on the lack of ethical behavior for many tech companies who are also the leaders in this field, a lot of companies are sort of waking up and saying, wow, there's actually a reputational risk here as well as an actual product risk. How do I get rid of the risk? And they don't think it through fully. They think, okay, I want to handle the reputational risk, not necessarily I want to build great products that actually make people's lives better. So I do think that instinct to ethics wash comes from that, where people are just trying to handle the risk in the minimal way possible. And also because doing this right is hard, and it also requires embracing a gray zone where you might make mistakes, and owning those mistakes can be expensive, but it is probably the right way to go.
Do we have time for questions? We do not have time for questions. Okay. Well, thanks for your time.
Well, thank you. And if anyone does have questions, I'm H. Mason on Twitter. Thank you all.